Hi guys, this is the second part of the transformations of exponential and logarithmic functions, and this part is all about the logarithms. So, just the same as we did the last video is how I'm going to do this one. Let's just jump right in and talk about all of the different parts that cause it to move. So the A value, again, this is reflections. I'm going to just say reflects over the x-axis. And that's, of course, if the A value is less than 0, if it's negative. The A value also does vertical stretches and compressions. Now, log base b, that is the information. That's like your parent graph. Log base b of x would be your parent graph. Okay, so that would just be your general information. That's not a transformation. Now again, look, it's on the inside. This h is on the inside with the x value. This is your horizontal transformations, your shifts left or right. And of course we have the k value, it's on the outside, and so this shifts up or down. And now remember, logarithms were shaped like this. And there was a vertical asymptote. In our parent graphs, the vertical asymptote was on the y-axis, which was x equals 0. Anytime you move the vertical asymptote left or right, so any shifts done to the function that are left or right, that's going to move the asymptote, okay? So we're going to do the same thing that we did on the last set of notes. First of all, the parent graph would have been log base 5 of x. So anything that is different from log base 5 of x is the transformation. So notice on the inside here, we have movement shifting left or right. Because it's on the inside, we think the inverse. So we're going to say this moved to the right one. This minus 1 is on the outside, and this is your k value. That means it shifted up or down, and in this case it shifted down 1. All right, so the asymptote here. The asymptote is changed if I move anything horizontally, and I moved it to the right one. So think about if you had your graph originally and the asymptote was here, and you moved it to the right one, you're now at x equals 1. Okay, so this is the new asymptote. So x equals 1 is your new asymptote. The domain, well, the asymptote here is what controls the domain. In the last video, it controlled the range. So we're controlling the domain here. We're not going past this asymptote, nowhere on the left. So for the domain, we're going to have x such that x is greater than 1. Because we're not going to touch that asymptote and we're not going past it. Now the range, on the other hand, we can go as high and as low as we want to on this graph forever and ever. So the range is all real numbers. Okay, let's try another one. And by the way, your function would look something like this. Of course, it would be shifted down 1 as well. So, all right, the parent graph here would have been log base 3 of x. Well, there's something happening on the inside here. Minus 1, we think inverse, so we think to the right one. And then outside here, we went up 3. This case is going to be the same as the other one, where since we shifted to the right one, our asymptote moved to the right one with it, so x equals 1 is your new asymptote. Again, the domain is affected by changing that asymptote, so the domain is x such that x is greater than 1, and of course the range is going to be all real numbers. Any shifting to the right or to the left will control. So just use this as a guide. Whatever you're saying happens, that's where your new asymptote will be. All right, we're going to apply some transformations to a given parent function. So here's your parent function. Okay, we're going to give it a new name, g of x. It wants me to vertically stretch the function by a factor of 2. So we're going to do 2 times log base 4. I'm not going to write the rest yet because I want to see what else is left. Shift left 2. Okay, left 2. That means I've got something going on inside with x. X left would look like negative, so I'm going to say plus 2. Change it because it's the inverse. And up 5. Shift up 5, so on the outside plus 5. And there you have it. Now in this case, if I were asking you, where is the asymptote? You should say at x equals negative 2, because this shifted left 2. So if it started here, it shifted left 2. So x equals negative 2. Okay? The domain would be, we didn't do any reflection, so the domain would be, you could go all the way up to that negative 2, but you couldn't go any further. So the x values such that x was greater than negative 2, and the range would still be all real numbers. All right, so again, talk to me if you have any questions.